guys, it's me again. So I'm going to be going over problem number 6, part A and B. So let's start with part A. It says suppose the B population is such that dB over dt equals 0.08b minus 1.1t, where b is measured in b's. For part A, use the method of integrating factors to solve the differential equation. So we have dB over dt equals 0.08b minus 1.1t. So what we're going to do to find b of t is we're going to use the integrating factors, which uses mu. So it equals 1 over mu times the integral of mu of t dt. And mu of t in this case is just going to be 0.08. So mu of t equals e to the negative integral of your a of t. So that would be our 0.08 here. So we put the 0.08 into the equation and we solve the integral and we get that mu equals e to the negative 0.08t. We plug that into this equation back up here for b of t, and we have this. I'm not going to say it all because it is super long, but then we're going to solve that integral. And we're going to put negative 1.1 over e to the negative 0.08t times the integral of e to the negative 0.08t times t, because we took out negative 1.1 times dt. And then we're going to, once we take the integral, this is what we get right here. Don't forget to add your constant at the end because that's going to matter in the long term. And then we're going to distribute all of this into each of these terms, which cancels out this e to the negative 0.08t and this e to the negative 0.08t. But we're going to have a c over e to the negative 0.08t. But in order to make that positive, we're just going to bring it up, and it's going to be c times e to the 0.08t. And then we distribute the negative 1.1 to all of our terms, and that's going to give us negative 1.1t over negative 0.08 plus 1.1 over 0.064, because we had a minus sign here and this would have been negative, so that became positive, plus our constant times e to the 0.08t. To simplify that, we're going to get 13.74t plus 17.2 plus c times e to the 0.08t, and that is going to be our solution to the differential equation. Now on to part B. Part B says using the concepts of limits and long-run behavior discussed in class, determine the minimum number of bees that need to initially be present in order to keep the population from dying off. So what we're going to do is we're going to have our solution that we just got in part A, and we are going to set c equal to 0 at time equals 0 in order to find our initial condition for b of t. So when we plug in 0 for t and plug in 0 for c, we get 17.2. So what this means is that at time t equals 0, we get that our bee population is 17.2, which means that our bee population must be greater than 17.2 at all times to have a positive constant in order for the population of bees to not die off. Thanks for watching. See you guys soon.